Hi, I'm Michaela Bedgood, and today we'll be exploring electron domain geometries through balloons, making balloon geometry. So all you're going to need to do that is you're going to need 6 different balloons, and you're going to have to blow all of them up individually and tie them. And you're going to need to tie them in certain orders. So after blowing up the 6 balloons, you're going to need to attach 4 of them, making like a flat layer, like all together, with 1 balloon on top and 1 balloon on bottom. It should look something like this. So here's my layer of 4, these 4 right here, and then 1 balloon on top, this pink one, and 1 balloon on bottom, this pink one. So this balloon arrangement demonstrates octahedral geometry. So let me set this down. So that demonstrates octahedral geometry. The total number of electron domains is 6, and the type of molecule that this shows is AB sub 5 with 1 lone pair. An example of this would be bromine pentafluoride. This balloon arrangement also shows another type of molecule, which is AB sub 4 with 2 lone pairs. An example of this would be xenon tetrafluoride. So now we're going to need to pop one of these balloons to continue looking at the different electron domain geometries. So next we're going to pop this bottom balloon right here. Just like that. So after popping the bottom balloon, you can see we now have these 4 and then the top one right here. Here, I'm going to cut the excess out. Alright, get the excess out, and now we just have 5 balloons now. So after popping the bottom balloon, we were left with these 5, which show a triagonal bipyramidal geometry. The total number of electron domains is 5. This arrangement has 3 different types of molecules. The first being AB sub 4 with 1 lone pair. An example of this would be sulfur tetrafluoride. The next type of molecule is AB sub 3, which has 2 lone pairs. An example of that would be chlorine trifluoride. And the last type of molecule is AB sub 2 with 3 lone pairs. An example of this is iodine monofluoride. So now we have to pop another balloon. So we're going to pop one of the bottom layer ones. I'm just gonna do this balloon right here. So now we are left with these 3 on bottom, and then this one's still on top. So you can see one sitting. So it's like a little pyramid. So after popping one of the balloons from the 4 that were on the bottom, we are left with these 4, showing tetrahedral geometry. The total number of electron domains in this arrangement is 4. This arrangement has 2 different types of molecules. The first being AB sub 3 with 1 lone pair. An example of this is ammonia. And the second type of molecule is AB sub 2 with 2 lone pairs. An example of this is H2O, or also known as water. So now we're down to these 3. So now we're going to pop another one. So now we're going to just pop, we're going to pop this one up here. So now we're going to be popping this top balloon. So and that one's popped off. And now we're just left with these 3, which lay flat. So after popping the top balloon, we're left with those 3 balloons showing a triagonal planar geometry. The total number of electron domains is 3. The type of molecule in this arrangement is AB sub 2 with 1 lone pair. An example of this would be sulfur dioxide. So now we are going to pop one more balloon. It doesn't matter which balloon you pop now, you just gotta pick one. I'm gonna pop this one right here. So now we're just left with these two. So the last balloon arrangement that we're looking at today in this arrangement with only these two balloons, and this arrangement shows linear geometry. So the total number of electron domains is 2 for this one. The type of molecule in this arrangement is just AB with 1, 2, or 3 lone pairs. Another type of molecule in this arrangement is A sub 2 with 2 lone pairs. An example of this would be nitrogen gas. So that was how you could show balloon geometry in your house.